So welcome guys again. Okay. Again, I was like scrolling through my YouTube videos. Okay. So I saw a video. A respected person. Okay. He's old person. His name is Shailender gaur. Okay. He has claimed like he developed an engine which can give mileage of 176 kilometer per liter. Okay, which is usually what the engine gives, and obviously usually more than 2 times the engine which he took and modified. So the mileage is 176 km per liter, which he is claiming. So in this video, what's our purpose? We will first know the physics behind this, whether the physics allow this or not, whether maths allow this or not, or if it allow, then what could be possibility, what could be challenge that is allowed. Okay. So first of all, let me show you his claim. Okay. His claim has been like posted on many big news channel, okay, verified ones and all, many big channel. Okay, so this I hope you, if you have seen this video, after many big channels covered his niche. Okay, so that's a good thing. So let's dive into physics. I guess it's visible. Yeah. So before knowing his claim, I would like to improve with the engine. It's a little intro. I will not gonna go into deep, because I mean I will intro this because if I tell the physics, you would able to understand it, and I believe you will get it into within minutes because you all are genius. Okay, so let's see his claim. No, I mean let's see engine. What is it? Is 4-stroke engine. Okay, this 1-stroke, 2-stroke, 3-stroke, 4-stroke engine. Okay, this 4-stroke engine, and first we will see how this works. So what happens? The air and fuel comes into engine with air as well. Okay, this intake valve open and engine comes, and when this engine comes, the intake valve intake valve is closed. When this air come, fuel come, intake valve is closed. This is intake. This process will be intake, and this process will be compression. When the fuel air has been arrived to piston or engine, the compression takes place, and piston moves upward, which compresses the air. So, and this is spark plug. So after compression, after the compression is as much his compression is to allow, after compressing that much, at some extent ignition happen. Okay, the spark plug fired and ignition happens. So when the fuel burns and the petrol burns, energy is released, and that energy suddenly pull down the piston, and that's how engine drives through energy. Okay, this engine rapidly pull down the piston, and which later move this and produce thrust. Okay, and after combustion happened, after combustion, the all exhaust which has been produced is passed through exhaust valve. Okay, this is passed, and all COT and all which you see like through your silencer, that passed out. So that's the basic 4-stroke engine works. Okay, and second, okay, you have got this, and no, actually listen, I am taking his only 2 claim, because as far this claim I have seen on videos. Okay, he has only given these 2 major changes. Okay, he does this and this change, and he has done and got 176 km per liter, and he has already patent his engine design. So I think if he had patent his engine design, he could reveal the engine to public at least, but it might be a reason. And if there is something he's hiding behind this 2 claim, which I will consider, if he's hiding much more behind this 2 claim, then I don't know, then I'm out. I mean, my validation will not be valid, because I am considering his only 2 claim, which as far I get from watching his tons of videos, being honest. Even doing web scraping, I got only his 2 claim. Okay, so let's dive into its first claim. What's his first claim? So here is like his first claim. So I took the screenshot from my YouTube video where he was describing like what are the changes he made into his engine, so that he got that much pretty great results. Okay, so this is the conventional piston. Okay, here this is at top dead center. This both feeder of piston is at top dead center, means where when the piston is at maximum compression, when he has at top where like just fuel gonna ignite. Okay, so at top pressure mostly our engine, general engine, which even the engine he used was at 0 degree. But what he did, he shifted it to 60 degree as far he claimed. Okay, he shifted it to 60 degree. It is the first claim he did, because it's drop frame center, it will not like send. It will, he said ki, I will not put here, I will put my rod here. Okay, or will start from 60 degree. Will start obviously from here. I mean this. Okay, so he claimed that I will start from here, coach. And obviously it is not new. Is it new? This isn't new. This is already been now. Invented many decades years before this convention and proposed offset thing. Okay, this isn't new. Now let's dive into his second claim. Okay, so his second claim is that he has a find like 6-stroke engine, which is that's good. Okay, so as we have far discussed the engine, okay, 4-stroke engine, you know, after third step, after this step, okay, after ignition, the temperature the temperature rises. Okay, and then at last step we know exhaust gas has been blown out. Okay, so what is this 6-stroke engine we do is generally like after ignition happens. Okay, and the gas has been thrown out. Okay, so the piston is still too much hot, because it is continuously working, continuously ignition is happening here. So again, this area is already too much hot. Already there too much thermal energy present in this video, in this area. So what 5th-stroke engine is, either it is inletted with water, we put water inside or air inside. So what happens? Water converted to steam. Steam expands. Steam takes much more volume, so steam expands, and expansion of steam pulls the piston down. Okay, and again drives the piston. Okay. So that's the analogy they use. Okay, so either it is two kind of, some people put steam here, some people put air here, both expand and drive the piston again. So you got it here, as you know, inlet of air, compression of air, ignition is happening continuously, so temperature of piston has already been increasing and already been there, and all exhaust gas has been blown out. Then water or air has been inletted through valve. So water is there now. Water phase of water has been changed. Water converted into steam due to heat of piston in there. Why? Because of ignition. Okay, so due to heat, the water is changed into steam, and that is steam drives piston downward, and then gives thrust, then gives extra energy. So what is happening here? After exhaustion, the heat energy of piston, which were not getting used earlier, now getting used. So that increases efficiency. And this is new. This is not new. The 6-stroke engine concept is already been there far, like I've been decades ago. It's been decades. It is there in market. So it is effective. It is not much effective. Even it has some efficiency. It still has some disadvantage has been from, and even it makes the engine size big, 2-stroke engine, and load increase as well. So there are many things. So research is still ongoing to make the perfect 6-stroke engine. Power has been already did it, and even if you search YouTube, many American citizens all posted videos, like YouTubers one developing 6-stroke engine. I have developed my own 6-stroke engine and all. So this isn't the new thing. Okay, this is already been there before. So this was his second claim. Okay, and now we will look to how these two claims will change the mileage of motorcycles. Okay, so in this we will take his where he told in a new channel, where he told like he converted his Bajaj Platina to 126 km per liter. So in this we will consider that Bajaj Platina as reference. Okay, so he did this thing. So we are discussing here only two things, as I told. Okay, if two claim of it, if he's hiding any other claim, I will not be worried, as I told. Like, okay, if as far I got to know, he had provided only two claim. So let's start debunking the physics, maths behind it. So let's develop a 6-stroke engine. Okay, developing a 6-stroke engine. Okay, so first I will let you introduce with this research paper, if it's visible. Okay, it's visible. So this is the research paper. Okay, yeah, this is the research paper. Visible. Let me make it visible for you, I guess. Okay, so this is visible, and this research paper is I will put the link of description here. This research paper of 6-stroke engine, he found BSFC had effective efficiency of 6-stroke engine, and he did experiment the guy who wrote this research paper and did the practical. What he did, he found the increase of 6%. Okay, 6% effective efficiency increase. As far you can see from graph as well, the 6% efficiency has been increased so far through his experiment and through his data. Okay, we are observing it. So using 6-stroke engine, it's been there. And if you say BSFC, okay, BSFC has been increased, and it's not a good sign of increasing of BSFC. Lower the BSFC, not good like engine. Engine is not measured in mileage alone, as the Shailender always measuring it in mileage. Main thing to measure the engine is this basic specific fuel consumption. Okay. So you can see basic stroke, this 6-stroke engine. Sorry, it is lower. Basic stroke, even BSFC of 6-stroke engine is lower. So you can see it's getting good. Okay, BSFC is lower, and even efficiency has increased. But there's other factor too, as I told, the load and the size of engine and that mechanical efficiency. Okay, so there's a lot of thing there, compression and all. So what we will do, we will take this data of 8% increment. Even this is data is not like put on the real bike, so this data is still more efficiency. We will here he claimed 6% efficiency. Okay, means this experiment was for 6% efficiency. It was 24% earlier. You can see it is 24% earlier, and it increased to 30%. Okay, after in this red line represents 6-stroke engine with water. Okay, you can see here, and this green line represents our conventional 4-stroke engine. So if Shailender converted his engine to 6-stroke engine, so in his we are assuming that his engine efficiency must be been increased up to 6% max. Okay, but still we are giving him like extra bonus. We are increasing it to 8% or 9%. Okay, let's say 9%. So what I have prepared few site here. Okay, few documents here. So effectively efficiency that Bajaj Platina he claimed is 126 km per liter. Okay, and I've scrapped the internet and ChatGPT and all. I got to know its effective efficiency when I calculated that. If it's effective efficiency is 22%, I calculated on the basis of data given by ChatGPT. So I'm not sure its effective efficiency is 22%. Okay, so after believing this research paper of 6-stroke engine, which is done on, okay, it is UK and UK based, some UK guys did it. I don't know, I will put the link, you will see there. So increasing 22% to 31%, we are still giving him favor that his 4-stroke engine efficiency have been increased by 9%, 22 to 9%, 22 to 31%. And let's say previous mileage, which is basic mileage of Bajaj Platina, I have considered as 60 km per liter. So if it has 60 km per liter, and even max we have given is 8% mileage, which is 6%, 8% mileage. So the increase, the new mileage will be 16 to 31 by 22, which is 84.5 km per liter. So the new mileage will be 84.5 km in a liter. Okay, so this is even I've given him like extra bonus. Okay, it's not say 8%, 9% increase, it's 6% increase, less percent increase like that. Okay, we have considered his first claim, which is 6-stroke engine. So applying his 6-stroke engine concept into his Bajaj right now 4-stroke engine, we have come into conclusion that the new mileage will be 84.5 km per liter. Okay, so after doing this, we will come into his shaft angle, which means his offset angle, which is set into 60 degree, as I've told. So if he told it like here, he did 60 degree. So how much this will change? So to measure this, we will come into our computer brake efficiency. We will take brake efficiency, which is product of mechanical efficiency and thermal efficiency. Why we are considering brake efficiency? Because brake efficiency is directly proportional to mileage if you're considering same load and same speed. Okay, so brake efficiency is mechanical efficiency into thermal efficiency, as we got to know. And let's see, the mechanical efficiency is generally friction lost. How much percentage is lost in friction? How much energy percentage lost in friction into sine theta? Okay, now the sine theta has been changed. Okay, sine theta is 60 degree delta. We are finding the change in mechanical efficiency because our target is find the change in brake efficiency, then find the change in percentage increase in mileage. So we could know like how much mileage has been increased. So here you are saying mechanical efficiency, change in mechanical efficiency is we are considering the lost in friction is goes like 5%, which is pretty optimum. Okay, and multiplying with the change in sine theta, which is change in after he offset his angle to 60 degree. So it will be sine 60 minus sine 0. Sine 0 is 0, we know. Sine 60 is 0.8066. how it came? It came by radian. You know, to convert the degree into decimal, we use radian and all. So you come into that, and that mechanical efficiency change will be this. So the old mechanical efficiency of Bajaj right now, which is considered, and I found on internet, is 85%. Now has been changed to 89%. Okay, and now calculating, we are calculating the thermal efficiency. Okay? So thermal efficiency, we have considered 0.30%, which I got from internet, which is pretty correct for the normal petrol bike like Bajaj Platina and all. So it's 30%, okay, thermal efficiency. And change in we are finding the change in brake efficiency. So change in brake efficiency will be thermal efficiency to change in your mechanical efficiency, as we have considered our mechanical thermal efficiency isn't changing. As I told, change in shaft, change in that offset angle, we considering top dead center starting from 60 degree will not change thermal efficiency that much. It will decrease that side resistance, but it's still not significant to count. Okay. So we are taking here a change in mechanical efficiency. We found ever, which is 0.04. Okay, we found change in mechanical 0.04. So after this, we found the change in brake efficiency. Change in brake efficiency is this one. So what was the new old brake efficiency? Applying the we found the old brake efficiency, but multiply theoretical efficiency, older theoretical efficiency, older thermal efficiency, and older mechanical efficiency. After applying that, we come to this older brake efficiency, which is 0.255. Okay, and we increased it by 0.012. So the new brake efficiency which will come to our picture is 0.26799. Okay, and what was our older brake efficiency? What was our old brake efficiency? It was 0.255, and you come to be 0.26799. So how much percentage of increase is taken place? How much percentage of increase is taken place? It's like 5.1%. How 5.1%? So let's see. We have to find that change, and it's old. Okay, so how much increase from the old? It has increased the 5.1% from our old efficiency, which was there. So it's a pretty great result. So as far ever after applying 6-stroke engine, we have get into the mileage of 84.5 km per liter. After we have got the mileage of 84.5 km per liter, and then we applying. Now we wanna apply this increase due to his second claim. Okay, so let's do this. So we will do a little calculation here. How much after applying our 6-stroke engine, we got the mileage of 84.5, and now this 5% increase in the efficiency, but still there is too much disadvantage as well for to get in, even putting that top dead center at 60 degree. Okay, so 5% increasing, it was 84% after applying first claim. So after applying second claim, it will be how much? So we will get 1.05 into 85.4. So it's net increase will be 89.67. So at max, after even applying his 2 claim, we are getting 89.6 km per liter. Okay, which is generally not increasing the efficiency that much. Okay, which he claimed, which was 136 km per liter. So that's mean he's lying. No, he might not be lying. He might be hiding many things, because he don't want to tell us, or like it might be a threat to him or threat to his life or something. There we would never be able to know the scene behind. But as far he's considering 2 claims, this one I'm telling to reason. If I consider his only 2 claims, this is the reason. Even if he done many things, piston length and all compressor resistance, then it might have get something. It might he modified it so much well. It might be possible. I'm not saying he's wrong. I'm literally like respecting the person like him who has given her life almost more than 10 years of life into some these things. So obviously he's into something. I believe so. So let's see. So let's see we're coming to our final guess. So let's see our final guess. So this is our final guess. Swiss design compares the stress to 15%, 10%, 5-10%, and our cylinder is claiming is 2 times, more than 2 times. Okay, which is not physically plausible with these 2 claim only, considering only 2 here. But let's see whether he's hiding lots of things behind us. And so let's see. So that much for today's video. Thanks a lot for giving your time.